We're going to discuss the NHT paper of 2026 that was held in May, and we're looking at the networks question 15. Each morning before the cafe in the estate can open, a project of 14 activities need to be completed. The activity network below shows a project with activities A to N along with completion times in minutes for each activity. State the critical path. Now, in order to do critical path, you have to do the backward and the forward scan. And so in order to do the forward scan, which is what we do first, we always choose the larger values. And so where two edges meet in the direction of arrows, we indicate so that it becomes easier for us to avoid making mistakes. Okay. Now, so we start with a 0 here, which is earliest starting time for activities A and B. And so that's 5, 0 plus 5, and along C, 5 plus 2 is 7. And then along B, 0 plus 5 is 5. Sorry, that was a mistake. And so of the two values, the larger value is 7. Now we go along E, 7 plus 4 is 11. And then along H, 11 plus 5 is 16. Now going along D, actually there's a choice that has to be made here as well, because there are two arrows coming to a vertex. 5 plus 7 is 12. And then going along the dummy, the value is 0. 7 plus 0 is 7. Larger value being 12. 12 plus 3 is 15. Of these two values, 16 is the larger value. Going along I, 11 plus 2 is 13. Going along L, 16 plus 4 is 20. Now coming along F, 7 plus 2 is 9. And then 9 plus 4 is 13. Coming along J, 11 plus 4 is 15. And 15 is the larger value. 15 plus 6 is 21. And of these three values, 20, 13, and 21, 21 is the largest value. And 21 plus 4 is 25, which is the minimum completion time. Now, going backwards, we can indicate where arrows meet when you take them back, when you go along the arrows backwards. So if you go this way, and so those are the three places. Another choice to be made here, and here, and here. So basically that's the most difficult part, and if you can identify those places which can cause you to make mistakes, you shouldn't have a problem finding the critical path. So let's start with making this 25, which is the finish time as well, and then subtract as we go backwards. 21 take away 4, 25 take away 4 is 21. Going along L, 21 take away 4 is 17. And then H, 17 take away 5 is 12. Going along I, 21 take away 2 is 19. And then going along M, 21 take away 6 is 15. And going along J, 15 take away 4 is 11. The smallest value is 11. Along E, 11 take away 4 is 7. And going along K, 15 take away 4 is 11. And 11 take away 2 is 9. Coming along the dummy, we have to first go to across G. 17 take away 3 is 14. And 14 going across the dummy, 14 minus 0 is 14. And the smallest value is 7. Going along B, 7 take away 5 is 2. Now going along D, 14 take away 7 is 7 here. And going along C, 7 take away 2 is 5. smaller value 5, and 5 take away 5 is 0. Smaller value of the 2 is 0. So if you get 0 along an edge, you're usually correct, okay? So now let's try and find the critical path. So we can see that the 0 here plus 5 is 5, and the two boxes are the same, which is good. And then 5 plus 7 is 12, but both the boxes are not the same there. So we go along C. 5 plus 2 is 7, and the boxes are the same. That's good. Now if we go along along F, we have 7 plus 2, which is 9, but the boxes are not the same. So let's go along E. So 7 plus 4. So it's always the earliest starting time plus duration time, okay? 7 plus 4 is 11, and the boxes are the same. Now you have three ways you could go, but if you look for the boxes which are the same, they're either this or this. Now which route should we take? We have 11 earliest starting time plus 4 is 15. The boxes are the same. We won't go along I because 11 plus 2 is 13, but no box shows 13. And we won't go along H because 11 plus 5 is 16, and this box is not, the 16, 17 are not boxes which are the same values. And so we'll go along J, and then that takes us 15 plus 6 is 21, and 21 plus 4 is 25. So clearly our path will be, critical path is that one, and so if we were to write that, it would be A, C, E, J, M, and N. Now they ask you to find the latest starting time for activity H. So let's identify where activity H is. That's this one. Now what I usually do is I look at the earliest starting time and the backward scan value, which is 17 take away 5 is 12 over here, okay, and I subtract the 2 and I get 1. Now the other way of doing it is, let's say this is activity H of value 5. The boxes at the end of these two are 11, 11 and 16 and 17. Now what you should do according to formula is LST minus the EST minus the duration, okay? So that would mean, sorry, here I was explaining the float time, but the latest starting time for this activity is this value along the backward scan, that's 12. In case you had to find the float time for that particular activity, because any edge that's not on the critical path will definitely have a float time, then you use this formula, and so float time would be LST minus EST minus duration, which would give you 1. And that would be a different question to find float time, okay? This is just a little revision of some concepts. Okay, so in order to find the latest start time, it's always good to go and see the value at the edge, the beginning of the edge, while doing the backward scan. State all the activities that have a float time of 2 minutes. Now I just explained the concept to you. So we know that activities that have a float time are not on the critical path. So now let's go have a look at all the activities. The easiest way is the first way I described, where you look at the earliest start time of the activity and the value on the at the beginning of that edge that we got doing a backward scan. Okay. So let's look at B. Now B has a value 2, and so the earliest start time minus that value is 2 minutes. I think it's in minutes for each activity. Okay. Now let's look at D. D has an earliest start time of 5 and a latest start time of 7, and the difference between them is 2. Now let's look at G. It looks like we haven't really done a backward scan. Oh, we have done a backward scan. 17 take away 3 is 4. And because multiple edges don't meet at this vertex, we can just take the earliest start time subtracted from the latest start time, and that will give me my float time. Okay, it's only when multiple edges meet that you look at the value at the beginning of the edge when you did a backward scan. So now let's look at L. And L was pretty simple because multiple edges did not meet it over here. And so 16 subtracted from 17 is 1 minute. And let's look at I. Now I is an edge, one of the multiple edges that meet at this particular vertex. So earliest start time of 11, and this is its latest start time. And the difference between the two is 8. That's pretty high. So I can be delayed for quite a while. And K can just be both subtracted, and so that would be 2. And F can be, obviously it's one of the edges coming to this point, and so you got to be careful. So earliest start time and subtracted from this value, which is 2. I think we've sort of covered most of the activities that are not on the critical path. So the important question is not how many. The question is state all the activities. So if I was to look at them in order, it doesn't matter, you can put any order actually. That is B, D, G, F, K. Okay, so B, D, F, G, and K. Now please don't write this because that would form a critical path. Okay, so put commas because you're stating the activities. There's each separate activity. The owners of the cafe want to reduce the total time to complete the project as much as possible. They have determined that the time taken to complete each of these activities can be reduced by either 1 or 2 minutes or left turn. So that's basically, in the other papers this is 0, 1 or 2 minutes. Okay, each minute by any activities by which an activity's completion time is reduced is associated with a cost of $20. Determine the minimum completion time and the minimum associated cost to achieve that particular time. Let's look at the activities that can be crashed so that we can get maximum reduction. So I looked at a few places which would actually give me a hint as to, so I first laid out the critical path, and then I saw some of the, so if you look here, okay, at this difference where the choices had to be made, it was a difference of 2. So I thought if I reduce 7 to 5, then I can have 5 as my next earliest starting time. So you reduce A by 2, okay, and to make it 3, and so 0 plus 3 will be now 3. So that's done a bit of reduction here. So let's now go along the path that cannot be reduced along D. So 3, the 3 here, plus 7 is 10. Okay, sorry, that 10. Now, because there's 2 edges, we have to come along the other edge as well to make a choice. Now we've changed 7 to 5 as the earliest starting time, the beginning of the dummy. And so that will cause this to change to 5 as well. Now, of the two values, the larger value being 10 is this value, okay? So let's go along G. I usually prefer to go along the activities that can't be reduced because that forms the limiting value, and then compare how much reduction is required along the path which can be reduced. And so 10 plus 3 is 13. Now let's come along E and H. So 5 plus 4 will be 9, and 9 plus 5 is currently 14, okay, if I hadn't reduced H. So let me reduce H by 1, and if I reduce H by 1 to make it 4, okay, so 9 plus 4 will now be 13. And so we choose 13, and so we've done one reduction of H, and that's that one. Now let's come along the path again that we think can't be reduced, not on the critical path. So 13 plus 4 is 17. Now let's come along I. 9 plus 2 is 11. Now most of the other activities seem to be on the critical path, so definitely there's going to be some reduction there, okay? So let's come along F. 5 plus 2 is 7. 7 plus 4 is 11, okay? Now those are the activities which are not on the critical path. So let's try and come along the other activities. 9, okay, earliest starting time of J, plus the current value of 4 will give me 13, okay, will give me 13. Now if I reduce that by 2 and make it J2 instead, okay, I will get now 9 plus 2 is 11, and so my new choice is 11. And then let's look at, should we reduce M at all? 11 plus 6 is 17. Now I can see another 17 along another edge, so it's no use reducing M anymore because I would have chosen this 17 anyway, even if that value is lower, okay? So we don't need to reduce M at all, and so 11 plus 6 is 17. So of the three values that we have at the edge over there, which are currently 17, 11 and 17, we choose 17, we choose 17, and 17 plus 4 is 21. So here we can see that we have also reduced J by 2. So these are the activities that we've reduced, and if we total the number, it's 5 activities to have a new minimum completion time of 21 minutes, and 5 activities reduced 3 activities reduced by 5 minutes in total, and each of those minutes incurs $20, and so that is $100. So let's answer those questions. Determine the new minimum completion time is 21 minutes and cost is $100. Keep practicing. Bye.